Today we're looking at graphing rational functions. We're looking at two types of graphs. F of x equals ax plus b over cx plus d, where the numerator and denominator are linear expressions. And number two, we're looking at the type where f of x equals a polynomial function at the top, expression at the top, polynomial expression at the bottom. So top bottom has a quadratic expression, bottom denominator has a quadratic expression. So we're going to look at these two problems. We're going to graph it. What we're going to find is the horizontal asymptote. We're going to find the vertical asymptote, the X-intercept, the Y-intercept, and we're going to find the point on the graph. So let's get started here. And this is hopefully easy to do for most of you. And if not, takes a little practice, that's it. First thing we find is the vertical asymptote. So I'm going to call vertical asymptote VA. That means the graph can never pass the vertical asymptote. So where is this fraction undefined? It's undefined when the denominator equals to 0. So that's what I'm going to do here. I'm going to set the denominator equals to 0. -3, -3, 2x equals -3. Divide by 2, and x equals -3 over 2, or -1 1/2. Okay. Next one, I'm going to look at the horizontal asymptote. This is where the graph approaches as x goes from -infinity to infinity. So what I'm going to do is, as x approaches infinity, I'm going to find the f of x value. As x approaches -infinity, I'm going to find the f of x value. Okay, so what I'm going to do here is, I'm going to bring this up more to the top here so you can see. What I'm going to do here is, I'm going to take this function here and I'm going to multiply it by 1 over x. I'm going to change the form of the function. 3x minus 1, 2x plus 3. I'm going to times by 1 over x. So you times by 1 over x, what that does is it leaves this, changes in the form so you'll be able to see the f of x value. Okay? So distributive property, 1 over x gives you 3 minus 1 over x. 2 plus 3 over x. Same function, different form. Okay? Remember now, these are asymptotes. It approaches but never reaches the asymptote. Okay, so as x gets bigger and bigger, 1 over x gets smaller and smaller, close to 0. This gets closer to 0, so your f of x approaches 3/2, or 1 1/2. Okay, likewise, this one approaches 3/2, 1 1/2. As x goes to the left, you get smaller, the fraction gets smaller and smaller, gets closer to 0. Never reaches, but it gets closer and closer to 3/2. Okay, we just found the vertical asymptote to be, or the horizontal asymptote in this case, HA, to be y equals to 1 1/2, and your vertical is -3 over 2, which is this one right here. So now what we're gonna do is, we're gonna get some kind of straight edge ruler, something that you can draw lines with. Okay, and I'm gonna make the markings here. So 1 2 3 4 5. 1 2 3 4 5. And this one is 1 1/2, so I'm gonna go 1 2 3 4 5. So this is 2 4 2 4, -2 -4, 1 2 3 4 5, -2 -4. This is the x-axis, this is the y-axis. Okay, so let's draw the vertical asymptote first. The vertical asymptote is negative 1 1/2. So this is negative 1 1/2 right here. And when we draw it, we draw dotted lines. So vertical asymptote x equals negative 1 1/2. And we draw the horizontal asymptote to be 1 1/2 also. So we're going to draw here. And your HA equals y equals 1 1/2. Okay. Now let's look at the part where we need to, so we got the vertical and the horizontal. How about we need to find the Y-intercept. The Y-intercept here is found by setting x equals to 0. So if we set x equals to 0 here, what we have is f of 0 equals negative 1 over 3. So negative 1/3. So negative 1/3 here is gonna be your Y-intercept. So I'm gonna call this 0, negative 1/3. Okay. The next one is your X-intercept. And that's where the function y value is equal to 0. So to get this fraction to 0, you need the numerator equal to 0. So 3x minus 1 equals 0. X equals to 1/3. So I'm going to place it here. Now you know that x approaches 1 1/2. So your graph, if part of your graph will have to pass through these 2 points, and it approaches that way. The next one will approach, the part of the graph will be here for the next one. How you determine that? I'm going to pick negative 2. F of negative 2 equals 3 times negative 2 minus 1 over 2 times negative 2 plus 3. Okay, so we have negative 6 minus 1, negative 7 over negative 4 plus 3, negative 1. This gives you a value of 7. There's no room here, so what I'm going to do is the graph always approaches your asymptote. So I'm going to make it approach my asymptote. However, somewhere here, I know it's not drawn to scale, but somewhere here I'm going to mark the graph negative 2 comma 7. This takes care of the point on the graph, the last part that we got to find. So we put this down here first. We took care of I'm going to write this down further here. We took care of the horizontal asymptote. We took care of vertical, X-intercept, Y-intercept, and point on the graph. Then we draw the graph, and that's what you're given here. Okay. For part 2, we'll look at the next graph here.